So on Wednesday, you're going to be doing a lab. And you're going to be looking at the law of constant composition, which when I asked you a question a long time ago, you had no idea what it meant. Well, the law of constant composition is this, that everything always combines in a certain mass percent, no matter what. When you did the magnesium oxide, it should have combined in a 60-40 percentage by mass. We could have used 500 grams of magnesium and only had maybe 2 grams of oxygen. It's always going to combine in a 60-40, no matter what. Hydrogen and oxygen, when it makes water, is always 11% hydrogen, 89% oxygen, no matter what. So no matter how much of the stuff you use, it always combines in the same amount. That is the law of constant composition. Okay? That they always, not that they always have that amount, they always form in the same percentages. Okay? So before, yes, sir.
If you have like a lot more oxygen than you have hydrogen, and they only combine, would you have like oxygen left over?
Tons of oxygen left over. That's called excess, and that's stoichiometry. That's what we're going to get to. You're going to tell me how much is left over eventually. Exciting. So before we can do any of that, we need to go back and revisit percent composition, because everything about empirical formulas is based on the percent composition. So, percent composition. So if you remember what a percent is, it's a part divided by a total. Okay, so a percent equals a part of something divided by the total times 100. That is a percent. Now we're going to be doing mass percents. So we're doing things by mass. Okay? Yes. Okay, good. So, I'm going to erase this because I'm in a really good spot with this camera and I don't want to change it. So if I have, let's go back to our K2SO4. K2SO4. If I want to know what percent is potassium, what percent is sulfur, and what percent is oxygen, I have to find the part and then the total. Let's find the total first. The total is basically the molar mass. What is the molar mass of potassium sulfate? Would someone please tell me?
$174.26.
In agreement? Everyone should be checking your own calculators. I do not want to see one. Logan? You did? What you say? No, I obviously did not. The scary person. Oh, it's not a scary person.
Does the doorbell not work?
Yeah, it works.
Oh, I read it twice, sorry.
You gotta kind of give it a wiggle.
Oh, that's why. Mr. Frankhoff would like to know if he can borrow a spray bottle.
Spray bottle. Does he have a cat problem?
I don't even know.
A spray bottle.
Thank you.
You're welcome. Bye.
Bye, see you later.
So, the molar mass was what? Who hollered out to me?
174.26.
0.26 grams per mole. Okay? So, what we're going to do, how much of that molar mass is potassium? So how much of the molar mass is potassium?
I got this.
How much of that is potassium? No, I'm not saying percent. I'm just saying gram-wise. How many grams?
78.2.
Thank you. 78.2 divided by 174.26 times 100. So you gotta take the part that is what you're looking for, divide by the total. Ah. And what was your percent? 44.88%. Right? Sulfur. What part of that is sulfur mass-wise? 32.06, 174.26 times 100. And what's my percentage of that? 18.40. What you said? 0. Okay. And in oxygen, what mass of oxygen is it? 64.00 divided by 174.26 times 100 is what? 36.73. Okay? That is percent composition. Every time potassium sulfate is formed, it'll always be by these mass percents, no matter what. That is the way it always forms. Okay? And that's what's going to lead us to the empirical formula. That'll be tomorrow. Yes, sir. Doesn't add back up to 100? What's it add back up to? 87.01. Okay. Let's see, so 78.2 divided by 170. So 44.88, 32.06. Oh, this is 21.77.
I added it wrong.
That's
21.77.
Wait a second. So 32.06, I had backwards. 32.06 divided by 174.26. 18.40 was right. Is this right?
Yes.
So does it have to be 100?
Yeah.
Okay. So that makes sense though, yes or no?